So today, me and my brother are going to teach you the differences between chemical changes and physical changes, and we're going to show you examples of each. Okay, so what I have in this water bottle is some vinegar, and what I'm putting in the balloon, or what I already put in the balloon, is some baking powder. And when I mix the two substances, what it's going to do is it's going to produce carbon dioxide, and it's going to blow up the balloon.
Oh, damn. You messed up.
Amanda? It's not gonna explode. You better do it. You better do it. You better do it. Outside. You see? So the balloon's slowly blowing up, and if you look inside, it's all bubbly up, like super.
Get that out of my face.
It might just explode.
Oh, damn.
Oh. Oh. Ta-da! Okay, you can stop it. Ta-da! What we have here is some rolled up paper towel, and when you when you burn the paper in oxygen, which is like our air, a chemical reaction takes place, which the fire turns the paper into carbon, which is also known as ash. It's a lot of carbon. I'm scared. Pure water, or hydrogen dioxide, has a freezing point of 32 degrees Fahrenheit. So let's see what happens when I put some water in the freezer for an hour. And temperature in my freezer is 2 degrees Fahrenheit. It's been like an hour. So let's check on our water. As you can see, the water changed its physical properties and it turned into a solid, and then it turned into ice. Go over ice and water, put it in here, and we're going to watch the water turn into its third physical state, which is a gas. But it's going to take about 5 minutes. So now our water reached its third physical state, which is a gas. The boiling point of water is around 100 degrees Fahrenheit, so right now the water is heating up and evaporating into a water vapor gas. Molecules are moving very, 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 very fast. That's why it's turning into a gas. What we actually can do is take all this water vapor gas, and if we put a cover back on top, the water molecules are going to condense and turn back into its original state, which is a liquid. It's all the water that condensed from a gas back into a liquid. Christian, what did you learn from this lesson?
We learned the difference between a physical and a chemical change.
And what do you think that is?
I don't know.
Well, I'm going to tell you. Well, a chemical reaction produces new substances by changing the way in which the atoms are arranged.
Oh, that's scientific.
In a chemical reaction, old bonds are broken and new ones are formed between different atoms. This breaking and forming of atoms takes place when the particles of the original material collide with one another.
Oh, cool.
So, Christian, what do you think of physical changes?
I think it's like you can physically change it, you can break it apart, melt it, freeze it, do whatever you want, but the element stays the same.
Like the chemical property doesn't change, right?
Yeah, all of that, it just stays the same.
Well, you are right. A physical change involves a change in a substance that does not involve a chemical reaction, as opposed to a chemical change. Since no reaction occurs, there are no chemical substances present after a physical change that were not there before the change. Because of this, a physical change is often said to be reversible. However, this definition is sometimes misleading, as many physical changes are difficult to reverse, such as cutting paper, or such as you eating that pizza and turning it into saliva mush, and it cannot return back into its original pizza state. Understand?